Dear learners, I am faculty of physics at SRN International School, Jagatpura, Jaipur. Today we will learn some topics taken from grade 11 physics related to chapter work, energy and power. And this is the second part of the video of this chapter. So let's start the video. First topic of this video is conservation of mechanical energy. So today we will learn that how mechanical energy remains conserved. So total mechanical energy of a system is conserved if the forces doing work on it are conservative. Conservative forces are those forces which conserves and do not changes. Consider a body of mass m initially placed at a point B at a height h from the ground. The mass of the ball is m. Now at a point A we will try to find the total mechanical energy. So here kinetic energy is 0 and potential energy is maximum, that is mgh. Now when we drop the ball from point B to point A, the displacement occur is x. So let's find out the final velocity. So v square is equal to 2gx according to the formula of kinematic equation of motion. So total mechanical energy is sum of kinetic and potential energy. So kinetic energy is half mvu square plus mgh minus x. So total mechanical energy remains mgh. Now when the ball is dropped to the ground at point O, then final velocity will be v square is equal to 2gh, then total mechanical energy will be kinetic plus potential. At the ground kinetic energy is what, the maximum, and potential energy is 0. So half mv square is the kinetic energy and we will solve it, we will get mgh. So we can say that in all the condition total mechanical energy remains conserved, which is equal to mgh. So now let's talk about next topic, that is potential energy of a spring. So we'll take a spring attached to a point and it is initially at unstretched condition. So the length of the spring in that condition is L and the point is A. Now the spring is stretched to a point B and the total displacement occur is X. Now the force applied by the spring to restore its original position, that is restoring force, will be equal to the displacement. So we can write F is equal to minus kx, where k is the proportionality constant which is known as force constant, and negative sign shows that the force is applied in opposite direction to the displacement. So this is the way by which we can express the restoring force applied by the spring. So let's talk about the work done so that we can find the potential energy. So here work done will be equal to force into small displacement dx. Now to find the total displacement or total work done from this displacement, we will integrate the total work. So dw is equal to kx dx and integration will give you w is equal to integration of dw. So dw will be equal to kx dx integration over initial to final point, and it will give you w is equal to half k L square, which is the total displacement conducted by the spring when a mass is attached to it. Now let's talk about next topic, that is various forms of energy. So there are various forms of energy exist in nature. Some of them are heat energy, chemical energy, electrical energy and nuclear energy. Let's talk about heat energy. So heat energy is that type of energy which we can observe or experience or obtain from rubbing two bodies. As we can see in the image, ancient man is using the two stone to rub, and with the help of that heat generates, and due to extensive heat obtained, fire catches. So next type of energy is chemical energy. So molecule participating in chemical reaction have different binding energies, and this chemical reaction will give us chemical energy. So we can say a chemical reaction is basically rearrangement of the atoms. there are two types of chemical energy, exothermic and endothermic. In exothermic, heat produces after the reaction. Here the example is Na plus Cl will give you NaCl. In this reaction, heat generates. Endothermic, in this reaction, total energy of reactant is less than the product. Next type of energy is electrical energy. So energy obtained from electricity, that is motion of electrons, will provide us energy. Such type of energy is known as electrical energy. Another type of energy is nuclear energy. So Einstein has proved in the previous time that energy is equivalent to mass with the equation E is equal to mc square. Now it suggests that if there are the conversion of energy can be done in terms of mass, or mass or energy are mutually convertible. So there are two types of nuclear energy, that is nuclear fusion and nuclear fission. Let's talk about fusion reaction. When four hydrogen atoms combine to form one helium atom, in this reaction the sum of the masses of reactant and products are different. So there will be less mass in the product, and this mass is converted into energy, that we call as fusion or nuclear fusion. Second type of energy is nuclear fission. Here one heavy uranium atom is converted into or split into light atoms, and the sum of product and reactant of mass will be different. The reactant is having less mass, and that mass is converted into energy. Now conservation of energy. Principle of conservation of energy states that energy may be transferred from one form to another, but the total energy is isolated remains constant. In a simpler way, we can say that energy can neither be created or not destroyed. It can only transfer from one form to another. In universe, total energy remains constant. If one form of energy is destroyed, not destroyed, we can say is just uh, removed from that particular space, and another form of energy is developed. So this is what conservation of energy is all about. It can only convert from one form to another, like electric energy can be converted into heat energy, like that. So this is what conservation of energy is all about. So that's all from my side in this video. Thank you so much. We have covered few topics in this video. Definitely we will cover the remaining topic in the next video. Till then, thank you so much. Bless you kids, and do like, subscribe our channel. Thank you.